Good morning, my dear students. Now we discuss dynamic voltage restorer DVR, dynamic voltage restorer. Dynamic voltage resource restorer is a DVR. It is used for distribution lines, not transmission lines. It's all used for distribution lines. This is a grid side, sending in voltage, sending in current, load side, load voltage, load current. So in grid side there is a one active rectifier, inverter, DC capacitor banks, series inverter, protection thyristor group, and also one transformer. So normally in distribution network there is a more voltage drop present in load side. In order to compensate that one, we using the dynamic voltage restorer. Normally in previous components, that is shunt capacitors or shunt reactors, all are the impedance changing devices. They changes the inductive reactance or capacitive reactance by adding the capacitors also or inductors. But the dynamic voltage restorer operation is different. This DVR directly supplies the voltage, how much that need the distribution line, how much the drop voltage, the drop will be compensated by using DVRs. How that compensate means the DVR always compare the grid side voltage to the load side voltage. How much variation is there, always compare that one. That variation voltage that will be injected by using grid side voltages. There is a one rectifier circuit. Rectifier circuit converts AC to DC. Here there is a DC capacitor bank. The main cause of DC capacitor banks that stores energy, which is here the rectifier circuit converts AC to DC. The DC is stored in DC capacitor bank. When they need the voltage in load side, so the DC again converted into AC, that much of voltage will be injected in distribution line. So the dynamic voltage restorer is a device that can be used in distribution network to inject three-phase voltages in series and synchronism with the distribution feeder voltages to correct short voltages reduction, the so-called voltage sags. The basic principle of dynamic voltage restoration is to inject a voltage of the magnitude and frequency necessary to restore the load side voltage to the desired amplitude and waveform, even when the source voltage is unbalanced or distorted. DVR is a power electronic based power quality compensation system that is connected in series with the grid. DVR provides effective protection by preventing the voltage quality events occurring in the grid from being seen on the load side with its high performance voltage compensation ability. DVR basically consists of a control system and a power circuit. The control system of DVR continuously monitors the grid voltage, detects the power quality events occurring in the voltage less than a half cycle period with the help of the control and detection methods, and generates the control signals required for the compensation. The power circuit of the DVR generates the compensation voltage and inject it into the grid in series to prevent voltage quality problems on the load side. Therefore, it ensures that the loads are protected from voltage quality problems occurring in the grid. The DC link capacitor bank is used to store the energy required for the DVR to meet the expected compensation requirements within the period until the active rectifier controller reacts at the moment of compensation. The schematic diagram of sensitive load protected by an ideal series compensator. In this, DVR is represented by an ideal voltage source that injects a voltage VI. VI is equal to VT plus VF. There are two different ways of constructing this device. The DVR can be constructed such that it is either capable or not capable of supplying or absorbing real power. Where VI is the load bus voltage, the DVR then can regulate the bus voltage to any arbitrary value by measuring the terminal voltage VI and supplying the balance through VF. When the DVR is not capable of supplying or absorbing any real power in the steady state, it may instead have to supply or absorb real power during transients. Note from figure that the current through the line IS is the same as the current through the load IT. Also, the phase angle difference between the load current I and the load voltage V is dictated by the power factor of the load. Also, for no real power injection or absorption, the positive sequence fundamental frequency component of the voltage VA must be in quadrature with the positive sequence fundamental frequency component with the load. So next class we discuss UPQC.